All right, let's jump into some 2-2 product and quotient rule notes. Got a two-part goal problem up at the top of the page there. If you need to pause the video, go ahead and take 60 seconds and jot down what you notice, what questions you might have, and then what previous math knowledge might help you if you were going to solve the goal problem for right now. Okay, I hope one of the things that you notice here is that we're taking a look at taking a derivative of a couple of different things. Okay, when we've taken a derivative of things in the past, it's been separated into terms. Okay, for example, we might have been taking the derivative of y equals, 4x to the third minus 5x to the second plus 12x minus 77 or something crazy like that, right? Where we could easily identify term, 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 and take the derivative of each of those individually, right? Today, I hope you notice that we're taking the derivative of things that are multiplied together in the first one, and in the second one, that are divided. So, our terms, like we had over here, aren't necessarily going to be the way that we're going to take the derivative. Now, this can inform how we're going to do it, but we're going to need to develop or take a look at some new rules to help us be able to take derivatives of functions that look like this. All right? So let's go ahead and jump straight in. I've got a product rule here, and I'm just going to give you this, and hopefully this is just going to be like a drill and kill situation. Hopefully we rep this enough times that it's sticking in your head here, okay? So I've started with the mathy definition here first, okay? And I'm gonna use highlighters to help us here, right? I've got an f function that's going to be blue, and then a green function that's going to be g, okay? And what we're going to try and do is just take the derivative of the multiplication of those two functions, okay? And the way that we're going to do that is and I'm going to add some numbers atop first. I do 1 d2, and when I say d2, that means take the derivative of 2, right? Do you notice that little prime signal right there? And then we're going to add 2 d1. Okay, so it's 1 d2 plus 2 d1. 1 d2 plus 2 d1. Okay, and we're going to, when we take the derivative of each individual function, we're going to take the derivative of that piece. All right, so let's see how it works. I think it'll make hopefully a little bit more sense once we take a look at it. All right, in example A here, I'm given h of x, and I'm asked to take the derivative. All right, and I'm going to highlight again. That's what I'm going to treat as 1, or the first function. And that's what I'm going to treat as 2, the green function. All right, so let's go ahead and try it. All right, I'm going to start with derivative of h of x is h prime of x, okay? H prime of x equals, and now let's go through and do it. 1 d2 plus 2 d1. So when it says 1, it's the same function, right? We haven't done anything to it. So when we do 1, we're just copying the first function. We're just going to copy 2x squared plus 5, and I'm going to leave it in parentheses. Now, d2. Now, we're going to take the derivative of the second function here, 3x to the fourth plus 5x plus 1. Now, that derivative, that is a thing that's separated by pluses and minus signs, right? Those are terms individual, so I can take the derivative of those individually. The derivative of 3x to the fourth, 4 times 3 is, should be in green, 12. X to the 4 minus 1 is third power, plus derivative of 5x to the first is what, just 5? And then the derivative of 1, any constant, is 0. So there's 1 d2. Now I'm going to hit plus, and now I'm just going to do the 2 d1. Now notice 2 is just g. Just copy g. And g is, what is it, 3x to the fourth plus 5x plus 1. And then the last one is d1. So we're going to take the derivative of 2x squared plus 5x. And again, notice that when I take the derivative of 1 here, I'm separated by pluses and minus signs. So I can take the derivative of each of those terms individually. So let's take the derivative of those terms individually. 2x squared, 2 times 2 is 4. X to the 2 minus 1 is 1. And then we have another constant. Derivative of 5 is 0. And so our derivative, h prime of x here, equals 2x squared, the quantity 2x squared plus 5 times 12x cubed plus 5, plus the quantity 3x to the fourth plus 5x plus 1 times 4x. So in and of itself, done. Now, for now, let's just leave it like this, okay? Yes, we could, there's 4 multiplication problems here, and we could simplify. We could distribute 4x over here and have fun with that. And then we could combine some like terms and do all that stuff. And we will, don't worry. You'll get the opportunity to do all that fun stuff. But for now, just leave it like that, call it a day, let's move on. Sound good? All right, let's do another example. I got an example B here for us. Now we're finding the derivative of g of x, okay? And again, I'm going to highlight because I like to highlight. There's my blue function, that's going to be my 1, and there's my 2. Did you notice that they were being multiplied there? I had one thing multiplied by another, product rule. Blue multiplied by green, product rule. Good? All right, let's try it. Let's go purple, why not? G prime of x equals, right, prime. Okay, 1d2 plus 2d1, 1d2 plus 2d1. 1 is just copying. 3x to the 5th minus 7x plus 3. Copy. 1d2 plus 2d1. 1 d2, d2, d2. Let's take the derivative of 2. And again, I'm separated by pluses and minus signs, right? So I can take the derivative of these individually. Derivative of x to the second power is 2x to the, first? And then the derivative of our constant negative 1 is 0. Boom. 1 d2, 1 d2, 1 d2. Plus 2. 2 is just straight copying, right? X squared minus 1 times the derivative of 1. And again, 1 is separated by pluses and minus signs, right? Because it's separated by pluses and minus signs, I can take the derivative of them individually using my power rule. So let's take the derivative of 3x to the 5th. What do we got? 5 times 3 is 15. X to the 4th, right? 5 minus 1 is 4. And negative 7x is what? Negative 7, right? X to the 0. We're good on that. And the derivative of constant 3 is 0. Boom. 1d2 plus 2d1. I think that's the wrong color. It's hard for me to see. I got a light in my eyes. All right, let's see here. Boom. 1d2 plus 2d1. Good? Good. All right, let's keep rolling. One more example. One more? Yeah, one more. Then you get to try it. All right, take a look at letter C. Find the derivative of y equals. Now, do you see the product again? Do you see a product here? Do you see boom, product, right? Train yourself to see what's going on here, okay? It's always easy to do the product rule in the product rule section of the notes. But to know when to use the rule when you're not in the product rule section of the notes, like, I don't know, on a quiz or a test or an AP exam or something crazy like that, right? You've got to be able to identify and go, boom, I see product, I know product rule, okay? Multiplying things together, product rule, done. Now, what do you notice about this one? I hope you all said, I noticed that there's a square root inside that guy right there. And when we had the square roots using our power rule, what did we have to do to take a peek at that? Didn't we have to rewrite that? So, you know what? I'm going to rewrite this before taking a derivative. I'm going to rewrite this as 4x to the second power minus 3x to the, remember turning that into 1/2 power, right? X to the first becomes the numerator. Square rooted, right? It's not there, but the 2's there. So it can be the denominator of that fraction. Times 2x minus 4. Oh my goodness, right? Do you remember doing that? Now this is what I'm going to let my blue function be, or my 1 function be, and that'll be my 2 function. All right, see that there now? All right, let's try it. All right, so I'm going to do y prime, right? Y prime equals 1 d2 plus 2 d1. 1 is just copying the function. 4x to the second minus 3x to the 1/2. d2, d2, 1 d2. Take the derivative of 2. Derivative of 2x is 2, right? And derivative of negative 4 is 0. 1 d2, 1 d2, plus 2, I'm just going to copy 2. 2 function is what, 2x minus 4? Times the derivative of 1. Now that I've rewritten this as x to the 1/2, I hope that these two terms right here are a little bit easier to take the derivative of. All right, so let's go ahead and do it. 2 times 4 is 8, x to the now first power, right? And I don't have to put that. Minus 3 times 1/2, 3 times 1/2, 3/2. So what do we get? Minus 3/2 x to the 1/2 minus 1, or 1/2 minus 2/2, so negative 1/2. Okay? 1 d2 plus 2 d1. Now, we didn't encounter this here yet. I think we're going to have to. Let me look down here. Oh, yep, we are. Okay. So I didn't put one of these in the example. Maybe this is an oversight by myself. But what happens, do you remember if we have something that we need to take the derivative of, like 3 over, I will call it negative 3 over x to the 5th? Do you remember how to rewrite that? So let's remember we can take this x to the 5th, and we can move it up into the numerator by making that exponent negative. So we can rewrite this as negative 3x to the now negative 5th power, right? And this, I think, oh, I thought I was highlighting there. This is much easier to use the power rule on than this. So when you get to this, you know, where you've got that x to the 5th or whatever in the denominator, remember, you got to go to something that looks like that before using your power rule there. Good? All right. I think that'll be good for now. You all give the next, I think it's 6. Look at that. You get 6 cracks at that one. Give those 6 a try. All right?